In this video, we're going to take a look at the mass transport systems of plants. So we'll explore how they transport their sugars, which is known as translocation, and their water, through transpiration. Plants make their own sugars through photosynthesis, but all of this photosynthesis happens in the leaves. So in order to share these sugars with the rest of the plant, so that they can be used for energy, they have to be transported somehow. This process is known as translocation, and it's mainly achieved by phloem cells, which are arranged end to end to form long columns that we call phloem tubes. If you look closely though, you can see that in between the adjacent cells there are lots of small pores or gaps, and these pores enable the movement of cell sap, which is basically a liquid mixture of water and sugar. This means that the sugars that were made in the leaves can be transported long distances through multiple cells. Once the sugars finally make it to whatever cells they're going to, they can be used for two things, either directly for energy, or they can be stored, so that they can be used for energy later. And one last thing to point out is that the phloem can transport substances in either direction, so up or down the plant. Next to the phloem tubes, we have xylem tubes. These are also made up of a column of cells, but this time they're dead xylem cells with no ends between them, so they effectively form one long hollow tube. And they're strengthened with a material called lignin. Their role is to transport both water and the mineral ions from the roots up the stem to the leaves, where the water can be used in photosynthesis. Now, the weird thing about the movement of water through a plant is that the entire thing is driven by the evaporation of water from the leaves. If you imagine all the water molecules as being arranged in one long chain, then every time that water evaporates from the leaf out of the stomata, it drags the rest of the chain up slightly, pulling along another water molecule to replace it. And as water is continually evaporating, because remember the stomata need to be open to let in the carbon dioxide, there will be a steady stream of water flowing up the plant. Now, the terms that you need to use when you're discussing this stuff can be a bit unclear, but basically, we call the evaporation of water from the leaves transpiration, and the chain of water molecules is known as the transpiration stream. There's always going to be at least a little bit of transpiration taking place, but the rate of transpiration can vary a lot, and there are four main factors that influence this rate: light intensity, temperature, airflow, and humidity. The brighter the light intensity, the more photosynthesis that can take place, which means that more stomata will have to be open to let in the carbon dioxide required for photosynthesis. And at the same time, more water can evaporate, which means a higher rate of transpiration. Whereas at night time, when there's no photosynthesis happening because it's dark, the stomata will be closed, and so there's very little transpiration. When it comes to temperature, the warmer it is, the higher the rate of transpiration, because the particles of water will have more energy, and so they're more likely to evaporate and diffuse out of the stomata. To understand the effects of airflow and humidity, it's worth taking a quick look at the inside of the leaf, and at how water diffuses out of it. Because water is continually being brought up from the roots, the inside of the leaf is going to have a much higher concentration of water than the outside. And this provides a concentration gradient down which the water can diffuse out of the leaf. So if you think about it, the rate of transpiration is really going to depend on the strength of this gradient. When airflow is high, for example it's really windy, then the water molecules that leave the leaf are quickly going to be blown away. And so the concentration gradient between the inside and outside is going to be kept high, increasing the rate of transpiration. While with humidity, which is a measure of how much water vapor is in the air, more humid air will decrease the rate of transpiration, because the large amount of water in the moist air will decrease the concentration gradient, meaning that less water is going to diffuse out, and so we have less evaporation overall. And that's everything for today. If you enjoyed it, then please do give us a like, and we'll see you next time.